So in this class, I will discuss the analysis of a Truss problem. It is a question paper problem, VTU question paper, June 2019. So this is the truss of the pin joint frame given with joints A, B, C, D. 4 joints are there, and there are 5 members A, B, D, B, AC, CD, and CB. It is subjected to one horizontal force 12 kN at C and another vertical force 18 kN at D. So we have to find the forces in the members of the truss. The question here is analyze the truss. Analyze the truss shown. Tabulate the forces. Tabulate the forces in the members. So he has not mentioned about what method we have to use. Let me adopt method of joints. So I will solve this problem by using method of joints. So there are two methods. One is method of joints, another one is method of sections. So method of joints, if you are using, we have to use the two equilibrium equations for the current force system. Sigma Fy is equal to 0 and sigma Fy is equal to 0, treating towards right positive and upward positive. And each joint is taken, and at each joint the equilibrium equations are applied. Now here, if you observe the problem, there are two supports here. One A is a hinge support, B is a roll support. The first step is to find the reactions. So we have to find out the reactions and the supports. As you know, hinge support will have two reactions in general: horizontal to the roller, horizontal to the hinge, and vertical to the hinge. And roller support will have only one reaction, which acts at normal to the roller plane. Now here, I will denote let me denote the reactions like this. Since you have only one horizontal force acting towards right, naturally your horizontal reaction at A will be acting towards left, and VA is the vertical reaction at A, and I will take RB as the vertical reaction at B. Now we have to find out these three reactions using the three equations of equilibrium. First I will use sigma Fx 0 for the entire truss, treating forces acting towards right positive, left negative. So 12 kN is acting towards right, it is plus 12. HA I have taken in the opposite direction. So therefore HA is 12 kN and the assumed direction is correct. We have got the positive value, therefore assumed direction is correct. Next, the second equation, I can take moment equation. Sigma Na is equal to 0. Clockwise moments I will take positive, anti-clockwise negative. So now I am here. So I have to find the moments of these two forces and also this reaction about the point A, and I have to equate it to 0. Now sign convention is clockwise moments positive. So this 12 kN is giving a clockwise moment, and the distance is 1.5 meter. So 12 into 1.5. Then this 18 kN is also giving a clockwise moment, plus 18 into distance is 2 meters. And this RB is giving an anti-clockwise moment about A minus RB into distance is 4 meters from A is equal to 0. These two reactions, they don't have any moment about it because they are acting at A. Now therefore from this you can get the value of RB. RB is 12 into 1.5 is 18. 18 plus 36. So if you bring that to this side, RB becomes positive. So 18 plus 36 divided by 4, which is 54 by 4. So you will be getting the RB value as 54 divided by 4, which is 13.5 kN. So since the given forces are in kilonewtons, reactions are will be in kilonewtons. RB is positive, therefore assumed direction of B is correct. Now the third equation is the vertical forces equation, sigma Fy 0 I will take upward positive, downward negative. So this 18 becomes negative, VA and RB will be positive. So the equation is VA plus RB minus 18 is equal to 0. So therefore VA is equal to 18 minus RB, which is 18 minus 13.5, which is 4.5 kilonewton. This is also positive, therefore assume direction is right. So this is the first step in solving a problem of a simply supported truss. First we have to find out the reactions. In the case of a cantilever truss, finding reactions is not necessary. You can move from the period. Now once you get this, now next step is to consider each joint one by one and apply these two equations of equilibrium to each joint to find the forces in the members. So since there are only two equations of equilibrium, because joint means it is considered as a concurrent force system, so we can find out only two unknown forces. So that means we have to choose a joint at which only two members are meeting at the first stage. So now let us consider this diagram. Here I can take joint A or joint B, because at joint A, CA is member, AD is another member. Only two members are meeting. So first I consider joint A. To find the forces in the members, I consider joint A first. So here I am writing the free body diagram of the joint now. So this is joint A. You have a horizontal reaction, vertical reaction at the joint A. Horizontal reaction HA is acting like this, 12 kilonewton. VA is acting like this, it is 4.5 kilonewton. And we don't know the forces in these two members. So I need this angle now. Let us calculate this angle. So suppose if you take this as alpha, so tan alpha will be equal to 1.5 divided by 2. So therefore alpha will be tan inverse of 1.5 by 2. So tan inverse of 1.5 divided by 2, which is 36.87 degrees or 36.9 degrees. So alpha is 36.9 degrees. Now the step is, so we know that initially we don't know the nature of the forces in the members. Let us assume that the members carry tension force. Tension force means we have to take away from the joint. From the joint A, let me assume away from A, like this and like this. Both the forces in the members I consider as tensile. So assume the forces initially as tensile. Show that the force is acting away from the joint. So this is FAC. I can write this as FAC. This is FAD. Assuming that they are tensile forces. Now apply the equation of equilibrium for this joint. So sigma Fx 0 I am going to use. So sign convention is forces acting towards right positive, left negative. So here 12 is acting towards left, so it is minus 12. FAD is acting towards right, so plus FAD. And we have resolved this force into two components. So like this. So horizontal component will be FAC cos 36.9 degrees. Vertical component is FAC sin 36.9 degrees. So I have to take this force now. It is acting towards right. So plus FAC cos 36.9 degrees is equal to 0. So you cannot solve this because there are two unknowns. So I will call this as equation 1. Now the second equilibrium equation we have to apply for the joint is sigma Fy is equal to 0. I will take upward forces positive, downward negative. So 4.5 is positive. FAC sin 36.9 is also positive. These two should not consider. So 4.5 plus FAC sin 36.9 degree is equal to 0. From this you get FAC as minus 4.5 divided by sin 36.9 degree. So you will be getting negative sign. Negative sign indicates that this is compressive force. Positive sign indicates tensile force. Negative sign indicates is compressive force 36.9, which is so 4.5 divided by sine 36.9, 7.49. So minus 7.49 kilonewton. So this is the force, compressive force. I write C for compression because it is negative. So FS is a compressive force. That means it will be acting towards the joint. Anyway, we substitute that value here in equation 1 to get FAD. Substituting for FAC in equation 1, you will get FAD. FAD will be equal to, if you bring 12 to the side, it becomes plus 12 minus FAC cos 36.9, which is 12 minus of minus 7.49 into cos 36.9. Substitute the value of FAC, whatever you have got, with the proper sign. So now it becomes 12 plus 7.49 into cos 36.9, which is equal to 17.99. 17.99, or you can take it as 18 kilonewton. So you have got this as positive, that means it is a tensile force. So please note that C is a compressive force, T is tensile force. Now, by considering the equilibrium of joint A, we got the forces in two members. One in FAC, that is AC member, and AD member. AD member is taking a tensile force, whereas AC member, it is a compressive force. So two values we got now. So that means the forces in these two members we got. Next we have to move on to the next joint. So totally there are 5 members. Out of 5 members, in 2 members we got the answer. Now I will consider the joint D. If you consider joint D, so there are 3 members meeting at joint D, and also a force 18 kilonewton is acting at D. Out of which this member force is known now, only we can find out the forces in members CD and DB. So next joint under consideration is joint D. Consider the equilibrium of joint D. So I will write joint D now. So this is D. A force 18 kilonewton is acting at D, and this is C. This is A. This is B. Out of this, you know the force in the member AD. It is tensile force. So tensile force means from the joint it is acting away from the joint like this. So this is how you have to take. So this force is 18 you got. So that you write right now. Now we don't know the forces in these two members. So assume them as tensile. Once again from joint D we have to take away from the joint like this. Assume it as tensile. F CD is this force. This is FDB. FDB and FBD they are same. So we assume tensile forces. Now apply equilibrium equations for this joint. Sigma Fx is equal to 0. Forces acting towards right positive. So 18 is acting towards left, therefore minus 18. This is acting towards right, plus FDB is equal to 0. Therefore FDB is equal to 18 plus 18. That means this is also tensile. Plus value you got, therefore it is tensile. Next, use the second equation, which is sigma Fy is equal to 0. Upward force is positive, downward negative. So only 2 are there here. FCD minus 18 is equal to 0. Therefore FCD is equal to 18 kilonewton. So this is also tensile because we got positive value. So now we got the forces in these two members now. This we got 18, this also we got 18. So both are tensile. Now these two. Only the last we need to find the force in the member BC. For that we consider the joint B now. Either joint C or joint B can consider. Anyway, joint B I will consider because only 2 members are meeting at joint B and reaction will be there at B. Now let me write the this angle is also alpha. 36.9 degree. This is B. This is vertical reaction RB. So RB is 13.5 kilonewton that we have to take. That's all. Now assume the force in this member BC. This is B. So as tensile force means it should act away from B like this. This is FBC. You have to find out FBC now. You know the value of FBD or FBB. It is 18 kilonewton. Since it is tension, so away from B I have to take. So this is 18. So this already we have got from analyzing the joint D. So be careful about the arrows. So away from the joint, whether it is joint D or joint B, away from the joint gives the tensile force, towards the joint gives the compressive force. Now we have to apply the equilibrium equation for this joint B. So we have to resolve this FBC. It is in the second quadrant. So these are the resolutions. FBC cos 36.9 degree. This is FBC sin 36.9 degrees. Now since only one unknown is there, only we need to find the force in the member BC. We can take only one equilibrium equation. Either we can use sigma fx0 or sigma fy0. I will use sigma fx0 towards right positive, left negative. So this minus 18 because it is acting towards left. Then this is also minus FBC cos 36.9 degree is equal to 0. That's all. You should not consider this because I am using sigma fx0. If you are writing sigma fy is equal to 0, treating upward force as positive, then the equation will be 13.5 plus FBC sin 36.9 degree is equal to 0. So you get the same answer for FBC, whether you use sigma fx0 or sigma fy0. Now FBC is equal to, according to this, it becomes negative minus 18 divided by cos 36.9 degree. So which will be, the answer is 18 divided by cos 36.9, which is 22.51 kilonewton with the negative sign. Negative sign indicates that it is compressive force. So like this we have to find the forces. This can also be found out. Either you can use sigma fx0 or you can use sigma fy0. Then also you will get the same answer. If you are using sigma fy0 for this joint B, 13.5 is positive plus upwards, and this is also upwards. So plus FBC sin 36.9 degree is equal to 0. So from this also if you simplify, FBC is minus 13.5 divided by sin 36.9 degree. Let us see what is the value of this. 13.5 divided by sin 36.9, which is also 22.48. Of course, 22.5 you can take. So whether you use sigma fx0 or sigma fy0, you are going to get the same answer. So in decimals there will be slight variation, no problem. So this is how we have to find out the, now we got the forces in all the members of the given term. There are 5 members. We got the forces in all the members. So first we got FAC, then we got FAD, then we got FDB, then FCD, then FBC. So like this we got the forces in all the members of the truss. So now after getting all the values, now you can tabulate the results. Tabulate the values in a tabular column. So tabulate the forces in the members he has asked. So let us tabulate the values. Now if I write the tabular column, it looks like this. Member, force in kilonewton, then nature, whether it is compression or tension. So there are 5 members. So tabulation is done like this. The first force we found out is FAC. So I will write force in the member AC. First I will write the member AC. 7.49 compression. So compressive force. C stands for compression, T stands for tension. Next AD 18 kilonewton. AD 18 kilonewton. It is tension. Whatever you have got, just tablet it. Next BD or DB. It is also 18 kilonewton. It is also tensile force. Then you have CD. It is also 18 kilonewton. That is also tension. And lastly, you have the force in the member BC 22.5, which is compression. So this is how we have to tabulate the values. 22.5 compression. So this is how we have to write the tabular column. C is compression, T is tension. So in the analysis, tension forces is treated as positive, compressive forces are treated as negative. So this is how we can solve or analyze a problem on a truss. So normally method of joints and method of sections we can use. Here I have used method of joints. The advantage is we have to use only two equations of equilibrium at each joint. The only limitation is we have to consider the joint where you have only two members meeting. So then only you can adopt this method. If they give simply supported truss like this, one hinge and another roller, first step is to find the reactions using the equilibrium equations. Then you have to take one by one the different joints. Here I have taken 3 joints because there are 5 unknown forces, 5 members are there. So from one joint you can find out 2 forces. Therefore, for finding forces in 5 members, at least minimum 3 joints we have to consider.